Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we have a problem. Today I want to talk about, in static electricity, charge interactions. So how do charged objects interact with each other? The main objective today is to learn the three ways that charges interact and be able to predict the charges given some data. So that's our big objective for today. But first, let's turn to a little video clip of a cool phenomenon. Now notice on this particular video, someone's going to pump up a balloon, got the yellow balloon there. And as they're pumping up the balloon, they're going to then put them next to some paper bits. Now paper bits, little pieces of paper, do not have a charge. And when you take the balloon, you put it next to paper bits, yep, nothing happens. Got it? Now they're going to rub the balloon in their hair, and that causes a transfer of charge as it's transferring electrons from the hair to the balloon. Now watch what happens. Again, the paper bits are neutrally charged, and whoa, cool, look what happens. That is super awesome. Now why does that happen? We'll learn more later. So to review, the balloon had a charge, but the paper bits were neutral. Super important. All right, so charge can be a force. All right, so something about forces that's weird about charge is this is going to be a force at a distance. Prior to this, at least in our class, we've been learning about contact forces. I can push on something. I can push on a wall, or I can push on something. I can apply a force, which is called a contact force. But we're now talking about something that can happen at a distance. You know, when I held the balloon up to the paper bits were attracted. Why were they attracted? Well, we'll learn about that later. But it didn't happen when they were touching each other. It happened at a distance. Or in other words, Now, one thing very interesting about electric force is that it can be one of two types of forces. It can be attractive, which we saw in the video clip, or it can be repulsive. So other forces can only be attractive. For example, gravity is only attractive. It cannot be repulsive. So there is electric force can be attractive or repulsive. So let's talk about the interactions. So there's three interactions, and I want to talk about the third is the weird one. But the first one is that if balloon A is charged and balloon B is charged, then they will repel. So this shows that them being repelled. And we'll actually do this in class, is that this is repulsive. The opposite, of course, is if balloon B and balloon C are attractive. So we've got attractive and we have repulsive. So there are attractive and there are repulsive forces. But you'll say, remember the objective was that there are three rules of charge interactions. Let's talk about each of them, and you're probably familiar with these. Number one, you've probably heard this. Opposite charges attract. So if I have two things that are opposite, then they attract. I'll bet you know number two. Like charges repel. So if I have two objects that are of the same, then they will attract. And then the third one, that's the one that everyone doesn't really think through, and that is that any charged object is attracted to a neutrally charged object. That's actually what we saw with the paper bits and the balloon. The paper bits, in fact, are usually considered, they are a good example of neutrally charged objects, and the balloon was charged, and you saw how they were attractive. And we've talked about forces just a bit ago, but let's make sure we understand that it follows Newton's third law. Newton's third law, that for every action there's an equal reaction, or we often say it's the law of force pairs. So I have an attractive, two balloons are attracted to each other. A is attracted to B and B is attracted to A. So F has a force on B, from B to A, from the blue balloon, if you will. And for the yellow balloon, the force of A is on B, and that causes them to attract. And we could just as easily do the reverse, as if they are repelling when C and D are interacting with each other. D has a force, a repulsive force on C, and then if the force on C is that C on D, that's the likes repelling thing. So they come in pairs, and the pairs are equal opposite forces. They come in force pairs. We've talked about force pairs a lot in this class. Here they are combined, but basically I would encourage you to draw the force diagrams, and they're either going to be repulsive or attractive depending on the situation. So let's now talk about what we know. So I would sketch this diagram, and what do we know? Here's our three rules down here. So if we've got A and B and they're repelling, what do you know? And remember, you got these three rules. Opposites attract, likes repel, and charged and neutral attract. If it's repulsive, the only rule down here that has repulsion in it is rule 2. So that means what we know about A and B is that A and B must be the same charge. We don't know if they're positive or negative, but we know that they're repulsive. All right, so what I would encourage you to jot down is that's what you know, right? Draw a picture of A and B and say all you know is that they are the same charge. But what if I have this picture? If I've got C and D, they're attractive. Now, if you look at our rules down here, we've got 2 rules that talk about attraction, 1 and 3, right? And so you know, well, what do you know? You know that they are either opposites or one is charged and one is neutral. Does that make sense? Because neutrally charged objects, we'll learn later why do neutral charged objects get attracted to charged objects. That's coming later, but that's a rule. So now let's do 2 examples. So sketch in your notebook these 2 examples. This is example 1. Now what we know in this particular problem is we know that B is positive. So it's a given. We know B is positive. Now what do we know about this situation? I have to look it up because it gets me a little confused. If we know B is positive, okay, we know B is positive. So what does A have to be? Well, if you look at the first picture, A is attracted to B. But all that tells you is that A could either be negative, right? That's the opposites attract, or it could be neutral. So that doesn't really help us too much. So all we know is, what's A's charge and what's C's charge? If B is positive, all right? But if we look at the second example, B is in with C, so B is repulsive with C. So if B is, so let's just do this here. If B is positive, we know that, right? Now what does C have to be? Since it's repulsive, and the only rule that applies is that for repulsion is rule 2, then we know C is also positive. All right, now what does that tell us about A? Does it help us at all? See, we don't know about A. We know that A is either negative or it is neutral. We don't know. So that's the best we can say in this example. B positive, C positive, and we don't know which is that. Here's a different example. It seems like it's the same, but it's not, right? We've got A and B are attracted. Again, B is positive. We know B is positive, and we're trying to figure out what A. But notice instead of being C and D or whatever, we've got A over in this second picture. So what do we know from the first one? If B is positive and A is negative, so we know B is positive. And actually, I would go to the second thing. Well, from picture 1, if you will, A is either going to be negative or neutral, right? But when A goes with C and they're repulsive, that means A has to have a charge. So that means A has to be negative. And then what does that tell you about C? Since it's repulsive, then C is also negative. So these are like thought questions, and you're going to get several of these like in your work and your homework, and you have to think them through by looking at a series of pictures to say what charges do they have. But the mistake everyone makes is rule 3, charged and neutral attract. Hey, Houston, we don't have a problem. We'll see you in class.